Hello everyone. And welcome back once again to another interesting video. In today's video we'll discuss about a complete roadmap to become a successful data engineering in 2023. So if you are ready, let's start today's video. Data engineering is a critical component of any successful data-driven organization. It is responsible for building and maintaining the infrastructure necessary for storing, processing, and analyzing data at scale. As the demand for data-driven decision-making continues to grow, the field of data engineering is becoming increasingly important. In 2023, there are several key skills and technologies that a data engineer must master to be effective in their role. This complete data engineering roadmap will cover the fundamental skills, tools, and technologies required for data engineering. From data modeling and data warehousing to data integration and ETL processes, this roadmap will provide a comprehensive guide to the most critical aspects of data engineering. By following the steps in this roadmap, you'll be well equipped to tackle any data engineering challenge that comes your way in 2023 and beyond. 1. Fundamentals of data engineering. Data engineering is becoming one of the most essential functions in today's modern organization as the inflow of data is growing at an exponential rate in any organization today. It is important to master the fundamentals of data engineering to become a proficient and successful data engineer. Here are the fundamentals to learn for data engineering. A. Computer Science Basics, for non-CS background learners. Fundamentals of Programming. Data Structures and Algorithms. Basics of Operating Systems. B. Programming Languages. Knowledge of Python and Scala programming languages. Knowledge of SQL and database programming. Designing and implementing data models and databases using tools such as MySQL, PostgreSQL. C. Basics of Linux commands. D. Data governance and security. Understanding of data governance principles and best practices. Knowledge of data security, privacy, and compliance regulations such as GDPR and CCPA. 2. Data storage and warehousing. Data storage and warehousing are important components of modern data engineering. With the exponential growth of data, it's critical to have an efficient and scalable storage solution in place that can handle large amounts of data. In addition, data warehousing enables organizations to store, organize, and analyze data from various sources in a centralized location, providing a more complete view of the organization's data. Let's look at the tools and technologies to learn for data warehousing. Familiarity with data storage solutions such as Hadoop, NoSQL, and columnar databases. Knowledge of data warehousing concepts and tools such as Amazon Redshift, Snowflake, and Google BigQuery. Experience with data modeling and schema design for data warehouses. Familiarity with distributed systems. 3. Data integration and ETL. Data integration is the process of combining data from different sources and consolidating it into a single, unified view. Data integration is critical for modern data engineering, as organizations often have data stored in disparate systems that must be combined to gain a comprehensive view of the data. ETL or extract, transform, load is a commonly used approach to data integration. In ETL, data is first extracted from source systems, then transformed into a format that is compatible with the target system, and finally loaded into the target system. ETL is a batch process that typically runs on a scheduled basis, such as nightly or weekly. Understanding of data integration techniques and best practices. Experience with ETL tools such as Apache NiFi, Apache Kafka, and Talend. Familiarity with data quality and data profiling tools to ensure the accuracy of the data being integrated. 4. Data processing and analysis. Data processing and analysis are key components of modern data engineering. Once data has been collected and stored, it must be processed and analyzed to extract meaningful insights. Data processing may involve cleaning, filtering, and transforming data to ensure it is consistent and accurate. Data analysis involves using statistical and machine learning techniques to identify patterns and relationships in the data. Let's look at the tools to master for data processing and analysis. Knowledge of distributed computing frameworks such as Apache Spark, Apache Flink, and Hadoop MapReduce. Experience with data processing and analysis tools such as Apache Hive, Apache Pig, and Presto. Familiarity with data visualization tools such as Tableau, Power BI, and QlikView. 5. Data pipelines and orchestration. Data pipelines are the backbone of modern data engineering. A data pipeline is a series of connected steps that move data from its source to its destination, typically involving data processing, integration, and analysis. Data pipelines are essential for organizations to extract insights from their data in a timely and efficient manner. Orchestration is the process of coordinating the various steps involved in a data pipeline. It involves scheduling, monitoring, and managing the different components of the pipeline, ensuring that data is flowing smoothly and efficiently through the system. There are many tools one can use to build data pipelines in an organization. Let's look at tools to learn for data pipelining. Understanding of workflow management tools such as Apache Airflow, AWS Step Functions, and Azure Data Factory. Experience with data pipeline design and implementation using tools such as Apache Beam and AWS Glue. Familiarity with containerization technologies such as Docker and Kubernetes for managing and deploying data pipelines. 6. Cloud computing platforms. Cloud computing platforms like Amazon Web Services or AWS, Google Cloud Platform or GCP, and Microsoft Azure provide a range of services for storing, processing, and analyzing data. These platforms offer a variety of benefits for data engineers, including scalable infrastructure, on-demand computing resources, and a range of tools for data processing and analysis. Apart from this, knowledge of DevOps principles and CI/CD pipelines would be an added advantage. 7. Conclusion. In conclusion, data engineering consists of many tools and technologies to master, but one needs not to learn each and every tool to get a job. You can learn a few of the tools or can specialize in one of the cloud platforms and you are good to go. If you are looking to learn any of the above tools, then you can learn from online courses or from YouTube. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.